Okay, so what I have here is just a couple of words that you need to understand exactly what they mean. I mean, you'll hear me use these words, you'll see these words like written in instructions. So first of all, you can be asked to determine the zero of a polynomial, okay? So if you're asked to find the zero of a polynomial, and I've put the letter A here in quotations because they actually, like just in notation in the textbook and some other notation that you'll see me use in a little bit, they're going to use the letter A just to represent a number, and that's what's going to be referred to as this zero, okay? So the zero of polynomials is just referred to as the letter A. This is going to be any value that makes the polynomial equal to 0. So that's why it's referred to as the zero of a polynomial, because it's going to be any number that you could plug into that polynomial that makes it equal 0. Those numbers are called the polynomial's zeros, okay? Now, you've done this before. It's just this is a new word. Whenever you've been given a polynomial and you've been asked to find the solution or to find the answer, you have been finding what is called the zero of a polynomial, okay? Actually, back in chapter 4, you had to factor, and then you had to solve the factors. You were finding zeros. That's just not what we called them there. We just said find the solutions, okay? Now, you're also going to be asked about the factors of a polynomial, okay? So, let me flip back over here real quick. These problems in which we were factoring, like for instance on this second example, the x that you have out front, that would be a factor of this polynomial. X plus 6 is a factor of this polynomial, and x minus 6 is a factor. So like this factor or this polynomial has 3 factors, okay? Same thing like on this example. This is a factor, this is a factor, this is a factor, okay? So when you're asked to factor something, then you're finding its factors, okay? Now, the format that you have for factors of a polynomial is x minus a. Now, here's this letter A, same thing that was used up here. So remember, the letter A represents a solution or a zero to the polynomial, okay? So if you know that solution, you could do x minus that solution and you would have a factor, okay? All right. So using that knowledge, here's the first thing that we're going to do. We're actually fixing to work backward. You're asked to write a polynomial in standard form with the given zeros. So you're going to start out with the zeros, remember, which is the same thing as solutions, and you're going to come up with the polynomial. Like I said, this is actually working backward of what you're used to doing. You're used to getting the polynomial and having to find the answers. You're going to know the answers and find the polynomial. So here's the 3 steps that we're going to follow. You have to write a factor using each zero. Now remember, just on the piece of paper right before this, you remember a factor is written as x minus a. Remember, that's going to be our format that we're going to use when we write a factor. Okay, so we're going to write a factor first, and then we need to multiply things out. So that means we'll either use the distributive property or we'll use the FOIL method. And then once we get everything multiplied out, then last of all we got to do is just combine like terms, okay? So here's my first example. So step 1 is to write a factor using each one. Okay, so I'm going to call my polynomial f of x. You can say y equal, h of x equal, but you know, you got to define, you got to give it a name. So I'm going to call it f of x. All right, so these are my a's. -3 is an a, 0 is an a, 2 is an A. So I've got to put each one of these numbers back up here in this x minus A, okay? So I would start with a -3, so I would have x minus -3. Now, x minus a -3 is going to change that to a plus because it's minus a negative. Then I would have x minus 0. And then I would have x minus 2. Okay, so I did x minus -3, x minus 0, and x minus 2. Okay, so there is step 1. Okay, step 2 is to multiply it out. Now, what I would suggest you do before we start multiplying this out, though, right here, since this happens to be a 0, sometimes you have a 0, sometimes you don't. X minus 0 is just x. So I'm just going to write it by itself and just put it out front here, okay? I mean, you could have left it in between or at the end, but I'm just going to, like I said, put it out front. Okay, so now when I go to multiply out, you can start in different ways. If you wanted to distribute the x first, you could, but do not distribute it through both. Like you could do x times just this one if you wanted to. But I'm going to start with the FOIL method. I'm going to FOIL the 2 parentheses out. I'm going to bring the x down like it is. And then let's just FOIL this out. So that's going to give me x squared minus 2x plus 3x minus 6. Okay, now I'm going to distribute my x. So I'd have x cubed minus 2x squared plus 3x squared minus 6x. Okay, so there's step 2. So step 3, remember, was to combine like terms. You do have these 2 terms here that are like terms. So a -2 plus 3 is a positive 1x squared minus 6x. This is your answer. So here's your polynomial, and this was its answers. So I'm saying we started with the answers and came up with the problem. Okay, let's look at another one.